Okay, we'll take one more numerical on this Euler's theory. So from booklet, problem number 15, page number 40. Problem number 15, page number 40. See, determine the Euler's crippling load for the I section shown in figure. So they have provided one I section. So this is the I section, which is cross section of the column. The length of column is 5 meter. Both ends of the column are fixed. Condition: both ends fixed. Condition is given. The dimensions are flanges, both the flanges of 200 mm. Total width means working depth is 400, and all the thicknesses are 10. Okay. They have provided E, modulus of elasticity. E is equal to 2.1 into 10 raised to 5 Newton per mm square. For both ends, fixed condition. For both ends, fixed condition. We have to solve this numerical. Now, the formula for both ends fixed condition, formula is, first I will write the original formula, pi square EI divided by L square. Now, the condition is, first condition, both ends hinged. Second, one end fixed, other end free. Third condition, one end fixed, other end hinged. And the fourth condition is both ends fixed. Means we have to take the fourth formula. Sequence baga. Original formula for second divide by 4, for third into 4, and for the last condition into 2. So here I am going to multiply by 2. Okay. So 2 pi square EI divided by L square is the formula for both ends fixed condition. Again, in this formula, what will have to determine? I. आता I कसा शोधणार सांगा? For I will require CG. Now, CG कसा काढणार? Y bar is equal to summation AY divided by summation A. करायची गरज नाही. का गरज नाही? Because this cross section is symmetric about its X and Y axis, so the CG is at its geometric center. Mention karo. As the given cross section is symmetric about X and Y axis, so CG of given I section is at its geometric center. CG is at its geometric center. So there is no need to calculate Y bar and X bar. Okay. So this is your CG. Now, the next step is to determine moment of inertia. So we will determine moment of inertia of this section, as we will require I minimum for this formula. So we will determine IXX and IYY. First we will determine IXX. So to get IXX, I am going to divide this I section into 3 standard rectangular shapes. So 1, 2nd and 3rd. So for the first section, the formula is BD cube by 12. So B is 200 into D 10 cube divided by 12 plus AS square, area 200 into 10 into H. H means distance of section CG of section 1 to neutral axis, that is XX. So this will be your H1. This distance is 200, 200 minus 5, so 200 minus 5 is 195. हे 200 कसं घेतलंय? Because it is at center, so this distance must be 200. So 200 minus 5 is 195. AH square. Okay, so this is for first one. Now write for second. BD cube by 12. B 10 into D height. 400 minus 10 minus 10. This will be the height of second section. So it is 380. So BD cube by 12 plus area 10 into 380 into H. Now centroid of this second and XX axis are lying. याचा अर्थ H is equal to 0. So H2 is 0. मी मुद्दामून लिहिलंय 0 square. Now for third, BD cube by 12, B is 200, D is 10 cube divided by 12, and if you measure distance from this one, then it will be 200 minus 5. So the first term and the third term both are same. म्हणजे flange 1 and flange 3 च्या value काय आहेत? Same. So as the two flanges are having same value, so I am going to multiply by 2. Okay? Solve, you will get IXX. झाले सॉल्व बाळांनो? हां 152.13 into 10 raised to 6 mm raised to 4. So this is your IXX. Now जरा लक्ष द्या सगळ्यांनी. We are going to solve for IYY. Now IYY will be equal to, आता अगोदरचा B म्हणजे काय असणार आहे तुमचा? D. So we have to convert B into D and D into B. So for IYY, this will be your B. So BD cube for section B is 10, D 200 cube divided by 12 plus A square. काय H0 सांगा? Because centroid of the section and Y axis will be lying on the same line. So it is 0. Plus for second, BD cube by 12, B 380 into D 10 cube divided by 12 plus A square 0. CG and Y axis एकाच लाईनवर आहेत. Again for third, BD cube by 12, B 10, D 200 cube plus A square 0. Y axis on this CG. Solve, you will get IYY. 13.36 into 10 raised to mm raised to 4. See, if you compare these two values, IXX and IYY, so IYY is I minimum. So I minimum is IYY equal to 13.36 into 10 raised to 6 mm raised to 4. So this will be your I minimum. Now, चुकले? गोटे 196.95 97.95 into 10 raised to 6. So if you compare IXX and IYY, then IYY is less. So I minimum is IYY. So we have to put this value here. So formula, Euler's formula for both ends fixed condition. The formula is, the case is 4, so we have to multiply by 2 to the original formula, pi square EI divided by L square into, because of the fourth condition, into 2. Okay, so put 2 into pi square into E, 2.1 into 10 raised to 5 into I minimum 13.36 into 10 raised to 6 divided by L square. Length is 5 meter, so 5000 square. Solve. 2.21 into 10 raised to 6 Newton. So the load required for buckling is 2.21 mega Newton or 10 raised to 6 Newton. एकदम सोपं आहे ना. एक 2-3 गोष्टी सांगतो, फक्त लक्ष द्या. हे प्रॉब्लेम एकदमच सोपे आहेत. 2 मिनिट फक्त लक्ष द्या. Suppose in the numerical, if they provide the circular section instead of I or T section, if they provide circular section, then Ixx and Iyy काय असते त्याचा? सेम. There is no need to calculate separate Ixx and Iyy. If they provide square, if they provide square, then Ixx is equal to Iyy. There is no need to calculate for this type of beams. अजून ॲड करतो. हॉलो सर्क्युलर सेम. ओनली काय होणार? आउटर सर्कल इनर्शिया मायनस इनर सर्कल इनर्शिया. बट Ixx and Iyy will remain same. Here also हॉलो स्क्वेअर. इसेंट्रिक नाही पाहिजे. काय पाहिजे? हॉलो स्क्वेअर म्हणजे सेंटर होल पाहिजे. अगेन Ixx इज इक्वल टू Iyy. पण जर रेक्टँगल दिला तर B and D xy, then Ixx is not equal to Iyy. In this case you have to calculate xx and yy separately. हे लक्षात ठेवा. मी थोडंसं अवघड गेलो आहे पेपरला येताना, ह्यातलंच काहीतरी आहे. हे सोपे आहेत एकदम. हां, मी मुद्दामून टी सेक्शन आणि आय सेक्शन घेतला आहे. कळलं? रँकाईनच्या वेळेला इन रँकाईन्स सेकंड केस विल टेक न्यूमरिकल्स ऑन सर्क्युलर, हॉलो सर्क्युलर अँड आय और टी सेक्शन. ओके, समजले सगळ्यांना? नक्की सगळ्यांना समजले? ओके, एक पॉईंट घेतो आणि थांबतो. हे लिहा.